So I'm going to type on this a little bit as we go because we learned some key features about this that we were finding. We had 5 of them. So we learned about holes. And what else do we have? We had horizontal asymptotes. We had vertical asymptotes, x-intercepts, and y-intercepts. Those are the 5 things that I wanted you guys to find with this. Now, when we go through and we think about finding them, what we're doing is I had you just dissect an equation and find these answers. What I want you to do with these type of problems, I want you to go from the answers back to the equations. And that can be tough, but you got to think about what you had to do to find each one of these answers to make this make a little bit more sense. So let's kind of review that. So when we found a hole, when we think about finding holes, this is, I'm going to type it so you guys can actually read it. This is the factor that canceled out when you did your initial factoring. So that means if you have a hole, its factor is going to appear on the top and the bottom of your beginning fraction, because when you factor it out, it's going to cancel. That's what makes it a hole. The horizontal asymptote is a little bit different, but a little bit tougher. But overall, this talks about the degrees of the bottom and top of the numerator and the denominator. You know, depending on whether we have y equals 0, y equals a number, or there's one on here that we didn't really talk about, but y equals an equation is a slant asymptote. It tells us about the degrees that the overall thing should have and how we can check it, okay? Vertical asymptotes. When you found vertical asymptotes, this was the factor that was left in the denominator. X-intercepts were the factors left in the numerator. And then y-intercepts were something you kind of got to go check at the end, but this is the value that we get when we plug in x equals 0. So if you think back to the way that we found each one of these, that's exactly kind of your description of how we found each one of these items. Okay? So we're going to list this and kind of work backwards. Now I think what also makes this tougher is that we don't have all of these features listed for each one of these problems. So let's go through and just list what we have. So this one says, let's start with holes. This one has a hole and it tells you its x value is at -3/2. It has a horizontal asymptote, and that is at y equals 0. It has a vertical asymptote, and that vertical asymptote is at x equals 1. X-intercepts. X-intercepts are also called zeros and roots. So x-intercepts are none. And that makes sense because its horizontal asymptote is y equals 0, so it's got an asymptote on the x-axis, so it can't touch it. And the last one we have here was y-intercepts. Does it list a y-intercept for this one? We've got zeros, holes, vertical, horizontal. It doesn't say anything about the y-intercept, so just ignore it. It's not part of the information that we have, so we can't say anything about it. Now, as you work through this, remember we want to get to a fraction. And what we have to do is we've got to start putting factors and terms back on the top and the bottom of this thing. So let's start with holes. Holes are going to come from the factor that's on the top and the bottom, meaning it'll cancel out. We just got to put it back in. So if we take this hole, we see that we have x equals -3/2. I need to solve that for 0 so I can figure out the factor that was supposed to go back in there. So I need to multiply this 2 over, add this 3, And what happens here is this, once I set this equal to 0, this was the factor that canceled out of both the top and the bottom of my fraction. So I need to write that back in. So that means there was a 2x plus 3 up here in the top and the bottom. That's what's meant by the holes when we go back to write the equation. So that one's done. Horizontal asymptote, y equals 0. We'll come back to that one in just a second. Okay. Vertical asymptotes. If you remember, vertical asymptotes were the factors that were left in the denominator. So we've got to take that x equals 1, and we've got to solve it for 0 to figure out what we should write in the denominator. So we minus the 1, we get 0, and that means this term needs to go into the bottom. So we get an x minus 1 down there. So we took care of vertical asymptotes now. Put a box around that one so I know I'm done. X-intercepts, there aren't any, so I don't need to worry about them here. And they didn't tell me a y-intercept, so I ignore it. So that's done. So right now I have a rational function that has these two features checked off. The only thing I need to double check is about this horizontal asymptote. Now, if you go back to the notes when we talk about horizontal asymptote, because it's y equals 0, it tells me about the degrees of the polynomials in the numerator and the denominator. So because it's y equals 0, what that means is that the degree in the top and the degree in the bottom, we're talking about the largest power, this one was smaller and this one was bigger. And really all we need to do to make sure that that works is in our answer, is that true? So if we multiply this out, the top would still be 2x plus 3. The bottom, we multiply this out, we get 2x squared. That's 3x minus 2x. That's plus x minus 3. This is what we have as our answer right now. Is the top degree smaller than the bottom degree? Yes, it is. Top degree is 1. It's a first degree. Bottom degree is 2. So therefore, that's second degree. First is smaller. So that one works and checked off. And we've actually written an equation that satisfies the information that we have. Now, we didn't have to deal with the x-intercepts and stuff here yet because this one didn't have it. So turn on your mic's question. You get it? We okay with that?
Yep, I got that one correct.
You got that one correct?
Yeah.
You good, Kia? Okay, I see you. Well, I'm going to do number 6, okay? Let me make it a little bit bigger so we can see it. So this one, I think what threw you off is that it gives you the horizontal asymptote as this equation. And this, when you get an equation, if you were to graph that, it's a line with slope. It's slanted. This is a slant asymptote. So it tells me something else about the degree that I just need to check. So let's list all of our information off to the side. So the whole is at x equals -3. We did horizontal and then vertical, right? So horizontal and vertical. So horizontal asymptote is y equals x minus 6. Vertical asymptotes, that's a none. X-intercepts, those are zeros. So there is 1 at 6, 0. So we took care of zeros. We wrote down the holes. There's no vertical asymptotes. There's no horizontal asymptotes. And notice that they leave out the y-intercept again. So since they leave it out, just ignore it. So remember, holes, we find the factor that's going to go on the top and the bottom of our fraction. X-intercepts we have to deal with. That's going to be a factor of the top. We don't have to worry about the bottom because there's no vertical. So let's work through it. You're going to be making a fraction out of this thing. So let's start with holes. This is the factor that canceled out of the top and bottom. So this is x minus 3, I'm sorry, x equals -3. So this is x plus 3 equals 0. So this is the factor that was on the top and the bottom of this fraction. So it's x plus 3 right here, and x plus 3 right here. So we're good with that. Horizontal asymptote is something we need to check at the end, so we'll come back. Now, vertical asymptote, this usually is the factor in the bottom. We saw that on the previous one, where it was the factor that ended up in the bottom. But because there are none, we don't need to worry about it. So there's no extra factor in the bottom. Now, the x-intercepts, those are the factors in the top. So this tells me that the x that we would have to deal with is equal to 6. That would be the solution to the factor in the top. So if we go and we solve this, we're going to get x minus 6 equals 0. And that means this factor goes into the top next to this x plus 3. So this is x minus 6. We took care of that one. And we don't have to worry about the y-intercept. So the only thing we need to deal with now is this weird thing that is slant. Now, I never had you find the slant asymptote yet, or the polynomial one, because we don't know the math to do it quite yet. But if we're given one that we know is an equation and not just a number, so this is slant, that means something though. It means something about the degrees of the numerator and the denominator. I'm sorry, I'm having some technical issues with my writing pad. It's not wanting to cooperate now. So let's just write bigger and smaller. So because we got a slant asymptote, that means that the top needs to be bigger than the bottom. So this needs to be a bigger power or bigger degree or power. This needs to be the smaller one. And really what we're doing is you just need to check to make sure that happens. With all the other information, this one should really take care of itself. Because if you get all this information in the right spot, you're going to have this setup. So if we go through and we check this by multiplying it out, the top, multiply that thing out, is going to be x squared minus 3x minus 18, and the bottom is just x plus 3. And the top degree is bigger than the bottom, and we've got all of our stuff checked off now. We okay with that one then too? I think we've hit everything but y-intercept, and we're going to kind of talk about that one on the graph in the next one. Question?
Nope.
That one okay?
Yep.
All right, let's talk about one with the graph, okay? And this graph one is tough because what makes this really tough is having to deal with the fact you can kind of see the y-intercept, but you can't really know exactly where it's at. The asymptotes are a little bit easier, but not that. But we're gonna work this one the same way. They're telling us the information, but they're doing it graphically instead of listing it out in words. So we still want to know where the holes are, where the horizontal and vertical asymptotes are, and then we want to list the x-intercepts if there's more than one, and there should only ever be one y-intercept for this. So holes. Now up here it says note points shown on the graph indicate holes. Now I did include this other one. You see where they put the big dot? What they're trying to say there is there's a hole in this graph at that spot. So for this one, I don't see any of those points. So that means there's no holes. Our vertical asymptote goes up and down. That's our horizontal asymptote. It goes left and right. Now that one's in between 0 and 1. So we're going to say that's about exactly halfway in between. We're going to say that's 0.5. Okay. Our vertical asymptote's the one that goes up and down, and that's out here at -3. Our x-intercept, that one's pretty easy to see. That one they're telling us is right there at -2, 0. And the y-intercept's the tough one. Now, I had it listed when I did it the first time. It looks like it's about 0.25. I know it has to be lower than the 0.5 because it's right here, but it's really tough to see and actually get that number. So this one, you kind of have to go, it's kind of like that because we're reading it off a graph. We're going to see if we're relatively close with our equation when we're done. So we still need to build our fraction just like we did before. We don't need to worry about factors that go on both the top and the bottom. We'll come back to this to check it. Our vertical asymptotes, that's our factor that goes on the bottom. So we need to go x equals -3 and solve that thing for 0. So that puts a plus over here. And that makes this one go on the bottom. So that means there's an x plus 3 on the bottom. So we got that. X-intercepts, that x value is a factor of the top. So that gives us an x of -2. So x plus 2 equals 0. That's the factor that needs to go on the top of our fraction. Took care of that. Now, y-intercept, we kind of got to go and deal with at the end. But let's look at the horizontal asymptote. Because we get y equals a number this time, what does that mean about the degrees in our fraction? Y equals a number means what? That the degree on the top and the bottom is the same. So again, this one right now, all we're really doing is we're checking to make sure the degrees match. Are the degrees the same in the top and the bottom of this? They are. They're both degreed 1. So that means that we are okay with what we have written down so far. There's nothing to multiply out. That one checked. The only thing we need to come through and figure out is the, oh wait, I'm sorry. The degree is the same. But because we got a number, we got to divide the coefficients. I apologize, guys. That's what happens when we record real time. This number, 0.5, comes from dividing the coefficients on the top and the bottom. And here's my board acting up again. Because it was listed as A over B. So let's write this without the, well, we can leave the parentheses. Right now, what's the coefficient in front of X? Somebody unmute their mic and tell me. Or type it in. Are you still with me?
Yeah, you said what's the coefficient in front of x?
Yeah, what's the number here? It's
0.
It's not 0 because it would be multiplying.
Okay.
It's a 1. That's right, Kia.
Yeah.
And then that means this one's a 1. So if we were to use this equation the way that it's written, is 1 divided by 1 going to give us the 0.5?
No.
No. So what we need to do is we need to put numbers out here that make it so when we look at the lead coefficient, we get 0.5 when we divide them. So I'm going to show you how to do that. And especially when you get a decimal, this can actually be a little bit easier, because how do you write 0.5 as a fraction? You write that as
1/2.
1/2. So that means the 1 on the top is okay, but what do I need on the bottom?
A 2.
I need a 2. I need that number to be what's in front. So what that'll change when I look down at my answer, now when I go through and I do this, this isn't going to be x plus 3 on the bottom when I multiply it out. It's going to be 2x plus 6. That's still a 1. That's a 2. That's going to give me the 1/2 that I wanted to make the y-intercept. I'm sorry, not the y-intercept, but the number for the horizontal asymptote come out. So that should be our equation. Now, the only thing left to double check, and this is where this answer is not going to match perfectly, because we guessed this number, right? We guessed that the y-intercept was 0.25. It should be something close to that. Now, the way that we would check that to make sure it works is plug in 0 for your x and see what your y value comes out to. So this gives us a y value of 2 over 6, which is 1/3. So that means this equation is telling me that the y-intercept should be 0, 1/3. Is that reasonable to say that that's 1/3 and not 1/4?
Yes, because it's
Yes,
still
it is.
close.
It's so close, and because that graph is so small, it's tough to get that exact unless you can actually see it going through one of the corner points, kind of like we did with this -2, and you know exactly what it's supposed to be. A lot of time with this one, you're going to have to just kind of check it at the end to make sure it's working out right. Okay?